Namaskar, Adab, Sat Sri Akal. How are you, students? I hope that your preparations are going very good. And here I am. Namaskar, Adab, Sat Sri Akal. How are you, students? I hope that your preparations are going very good. And here I am back again with a new chapter of our sprint series, that is current electricity. Current electricity. It is not false to say that it is the most important chapter of your preparation of JEE. Reason is there. If you are watching this chapter overview, you will see that very minimal number of formulas are there that you have to apply. Okay. And the concepts are also not that much tough in this chapter. And the weightage that you will see, if you are having good luck, you can have also 3 questions in a single paper from this chapter. So that's why it becomes a very chapter for us. Very easy concepts, minimal number of formulas, what else we need in physics. Okay. So as now, like in our series that we are making the chapters like bonus questions for us, we will make this chapter also the end of the session. I can guarantee you that. So be with me, take out your pen and paper, and let's start with me. Start solving it. Okay, I will give you some time also for solving all the questions, and then we will see where you are making the mistakes, where you can make the mistakes, and then you rectify your mistake. That is the proper method that you always follow. Okay, so we start. Okay, without wasting any time, let's start. Firstly, you have to study some basic formulas in this chapter regarding drift velocity, current, what is current, rate of flow of charges called as current. From there, some important formulas are there that I am telling you that you can remember. First one is drift velocity into E. Drift velocity is defined as mu into E. Here mu is called as what? It is called as mobility. It is called as what? Mobility into electric field. Now drift velocity is also defined as Et by m into E, and when it is divided, it will be changed like this. Now some more formulas also. Current is defined as eta E A B T. Very important formula. What is this J? Current density. Current density can be said as current per unit area. Right? Then you can just put the values of VD and the rest of the things you can write, and then you will have a relation J is equal to sigma E. This complete coefficient of electric field is taken as sigma. Now this sigma is called as electric conductivity of a material, and after further we derive that it is actually 1 by rho. Now what is this rho? Rho is nothing but the resistivity. It becomes 1 by rho in further chapter, and what we call resistance. Remember the formula resistance is equal to rho L by A. This rho is coming from here. It is equal to nothing but 1 by sigma. These are some relations that we are looking for. Resistivity depends factors on temperature. How resistivity is dependent and how resistance is dependent. This kind of formulas also you have seen in linear thermal resistance function. The formula is somewhat like this: rho T is equal to rho naught 1 plus alpha delta T. Same thing is written here also. And if I talk about resistance Kirchhoff law, very important law. How we apply Kirchhoff law? Let's see. We understand. Now there are two laws, KCL and KVL. What KCL says that I can write that sum of all the currents coming at a node is equal to 0. Okay. Or either you can represent also that if some current is coming from this side, it is split into two sides. So I1 current Namaskar, Adab, Sat Sri Akal. How are you, students? I hope that your questions are going very good. And here I am back again with a new chapter of our sprint series current electricity. It is not false to say that it is the most important chapter of your preparation of JEE mains exam. Reason is there. If you are watching this chapter overview, you will see that very minimal number of formulas are there that you have to apply. Okay, and the concepts are also not that much tough in this chapter. And the weightage that you will see, if you are having good luck, you can have also 3 questions in a single paper from this chapter. So that's why it becomes a very important chapter for us. Very easy concepts, minimal number of formulas. What else we need in physics? That's it. Okay. So as of now, like in our series that we are making the chapters like bonus questions for us, we will make this chapter also bonus in the end of the session. I can guarantee you that. So be with me. Take your pen and paper, and let's start with me. Start solving. Okay. I will give you some time also for solving all the questions, and then we will see where you are making the mistakes, where you can make the mistakes, and then you rectify your mistakes. That is the proper method that we always follow. Okay. So we start. Okay. Without wasting any time, let's start. Firstly, you have to study some basic formulas in this chapter. Regarding drift velocity, current, what is current, rate of flow of charges called as current. From there, formulas are there that I am telling you that you can remember. First one is drift velocity is defined as mu into E. Drift velocity is defined as mu into E. Here mu is called as what? It is called as mobility. It is called as what? Mobility into electric field. Now drift velocity is also defined as Et by m into E, and when it is divided, it will be changed like this. Now some more formulas also. Current is defined as eta E A B, very important formula. What is this J? Current density. Current density can be said as current per unit area. Right? Then you can just put the values of VD and the rest of the things you can write, and then you will have a relation J is equal to sigma E. This complete coefficient of electric field is taken as sigma. Now this sigma is called as electric conductivity of a material, and after further we will derive that it is actually 1 by rho. Now what is this rho? Rho is nothing but the resistivity. It becomes 1 by rho in further chapter, and what we call resistance. Remember the formula, resistance is equal to rho L by A. This rho is coming from here. It is equal to nothing but 1 by sigma. These are some relations that we are looking for. Resistivity dependence factors on temperature. How resistivity is dependent and how resistance is dependent. Linear thermal expansion. The formula is somewhat like this. Rho T is equal to rho naught 1 plus alpha delta T. Same thing is written here also. And if I talk about resistance at temperature T is defined as rho naught in bracket 1 plus alpha delta T. Same thing is written here. Rho naught 1 plus alpha delta T. This T minus T naught can also be written as delta T. Kirchhoff law, very important law. How we apply Kirchhoff law? Let's see. We understand. Now there are two laws, KCL and KVL. What KCL says is that either you can write that sum of all the currents coming at node is equal to 0. Okay. Or either you can represent also like if some current is coming from this side, it is split into two sides. So I1 current is equal to I2 plus I3. This is also can be written as for KCL. And then I will tell you how KVL. First we focus on KCL. How we write the equation. Net current at a junction is equal to 0 that I have told you. Here what is shown? This is current I1, this is current I2, this is current shown I3. Okay. So how I am writing? If this is in this direction, if let's suppose this I3 is in this direction, how I will write? I1 plus I3 is equal to 0. But the direction for I3 is actually against this. So how I can write I3 minus of I3 is equal to 0. Or also it can be stated that I told you if two currents it is moving like what? If I draw the actual diagram of the movement of this I3, it is looking like what? It is looking like this I1 and I2 are coming, they are joining and then they are moving for I3. This kind of current is flowing into it. So it can also be written as I3 is equal to I1 plus I2. These kind of things are very obvious to you. You are studying this KCL and KVL from the basic classes. Come to KVL. For KVL, remember 2-3 important things. When you are going from lower potential to higher potential, it will always be taken as positive. First assumption. Second assumption, now it can be either side also, but what standard things if you are going in the direction of current, the potential difference across a resistor that you write that will also be written as negative. For example, what I am trying to say, don't focus on here, just focus what I am writing the equation here. Start moving in the circuit, make a loop. Let's suppose current I is flowing into the loop and start moving. Let's suppose you have started from point A, we will assume some VA is the potential point A. Now what is coming in the next step? Lower potential to higher potential. What is right? Plus E plus then R1. What you can write potential across R1? You can write minus of I into R1. Correct? Then again this one minus of I then this one minus of I into R3. What I told you, I am writing the potential difference across and all these signs are negative. Then see, can I say all these potentials are same and again I have reached to what point? VA. Can I say this VA will simply cancel and if it is cancelled, can I write E is equal to I is common R1 plus R2 plus R. Can I say same equation is written? Result is not important, not at all important. The results are how you are writing every single term that is most important that you understand. Combination of ratios, very obvious thing from the basic classes which you are studying. Some basic points you have to remember. This is called a series combination end-to-end connection, but I will prefer that remember that if current is flowing same in all the resistors, that means combination is series combination. If current is divided into branches, or you can say if potential difference across each resistor is same, then it is called as parallel combination. For example, just like here, see what you can say. Let's suppose this point is 0 potential, that means this point will be E potential. So what I can say about R3? Potential difference is E, potential difference is E, potential difference is E. If potential difference is same across all these three resistors, that means what I am going to say, it is a parallel combination. Here you can see, here what I can say, whatever the current flowing through R1, it is the same current flowing through R2, it is the same current flowing through R3. If the current flowing same through all the circuits, all the resistance, then it is called as series combination. Meter bridge. Meter bridge is simply there is the equation. We use a jockey to find a null point. How we write? There is an unknown resistance that is applied here. So simply take the ratio of this distance. What you say R by L is equal to S divided by what is L? This complete length is 100 centimeter, so it can be written as 100 minus L. Correct? So it can also be written as like it is written here R by S is equal to L divided by 100 minus L. It's your choice in whatever way you want to remember, you can remember it. Combination of cells. How you write the combination of cells? The important formula. EMF are connected into series. How you write E equivalent? E equivalent can be said as E1 plus E2 plus E3 and so on. And if n number of EMF are connected for same EMF, n E will be the resultant. And let's suppose R number of resistance, n number of resistance are connected in series. R equivalent will be simply R plus R2 plus R2. These small resistance are what? They are called as internal resistance. This is also something that you have to remember. See a parallel combination. Parallel combination, the formula is a little bit complicated that you have to remember. That E equivalent is given as E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R. This is the formula for E equivalent in parallel connected package. And you already know the formula for this resistance that you are equivalent. Heating effect of current. What is the heat that is getting out due to resistance? Because resistance is what? It is the resistance is the offerance of it is not allowing, it is a property of a material to not allow current to pass through. And when it is applied, it increases the temperature, it releases some heat from the system. That heat is given as work done is equal to V into I into T. Also, it can be said as I square RT. Also, it is written as V square by R. Same thing, it is converted to the work done these formulas are important to remember this. Now we will directly start from questions and whatever the concepts that have been left, because there are variation of questions that we are going to see. So everything you will understand at the end of the session, that you will be feeling very confident after that you will cover all the variety of questions that are coming in JEE's exam. One more formula if I will tell you, that is power. Power is equal to V into I. That is a basic formula that I guess all of you know. That can also be written as I square by R and V square by R. I square R and V square by R. That also we are going to use a lot in this topic. So let's begin from the first question, and like we always do, I will give you some time firstly. This is our timer. You have to solve this question in the given time period, and then we will discuss that question. Be ready with your pen and paper. First question, I am giving you 1 minute, sufficient time. Start. Firstly, you have to find the effective resistance between A and B if resistance of each resistor is R. Calculate the effective resistance. If anyone knows about this circuit, this is a symmetric circuit. How to solve symmetric circuit, you will learn that. If anyone knows the concept, I guess their answer never will come, because it will become very simple. That is looking complicated. The actual question is not that much complicated. Six, 5, 4, 3. So let's see how to solve this question. This combination is given to you, and what I told you that it is a symmetric circuit. The property of symmetric circuit is at the symmetry point you can remove all the resistance. You can remove this resistance also, this resistance also. This is the property that you use in symmetric circuit. series. These two are becoming in series, and these two becoming in series. All these three series combination will become parallel to each other. That means what I can also draw. This point is A, having resistance, having three resistance here, and here also one resistance, and this is point B. What are these resistance I can say? 2R. This will become 2R. This will become 2R. This will become R. This will become R. Now how you can solve it further? 2R, 2R, 2R divided by 3. That means what is the next equivalent diagram you can draw? In this exam, you have to do these things in you don't have to draw this much of diagram. This will become R. This will become 2R by 3. This will become R. That means now what is the equivalent resistance you can say? 2R plus 2R by 3. How much it will become? 6R. That means 8R by 3. 8R by 3, which option is coming correct? Option is it clear? We just have solved it step by step. We have drawn the effective resistance diagrams, and then we have solved this. Just analyzing the concept that at the symmetric point we can remove the resistance. Solve this one. Good question. To detect the resistance via a circuit is designed below. The VI characteristic is also given to you. The circuit is plotted for the voltmeter. The ammeter readings as shown in the figure. The value of the resistance. The value of R you have to calculate actually. What is R? Let's see. How to solve this question. A curve is also let's see what the value that I can get from here. This is a circuit. What are the things that you can say? Ammeter is connected, voltmeter is connected. Let's take the 4 volt at this moment. Let's say 4 volt battery is connected. What is the current corresponding to that? 2 milliampere. Correct? That means I can use V is equal to I into R at this moment. What is the R equivalent? Also write as 1. Two resistors are connected and both are in parallel combination. Parallel combination they are connected. That means R equivalent can be said as what? R1 into R2 divided by R1 plus R2. It can be said as 10 or 1000 R divided by 1000 R. Sorry, not 1000 R. 1000. 10 that is 10,000. This will be the equivalent resistance. And now what I can say? I can say I is equal to E equivalent divided by R equivalent. Now what is the current that is flowing at this moment? 2 milliampere, that means 2 into 10 10 power minus of 3 is equal to E equivalent. E equivalent how much you can say? E equivalent at this moment is 4 volts divided by R equivalent. How much R equivalent you are writing here? It is 10 power 10 kilo, that is 10 power 3. 10 power 3, 10 kilo volt, that means 10 into 10 power 3, that is eventually 10 power 4. 10 power 4 R, and here it will multiply 10 power 4 plus R. Correct? Now let's see how to calculate it. Here what I can write? Here I can write 4 into 10 power 4 plus, then I can write 4 R. Here what I can do? I will multiply it here, and then I will have the answer as multiply it here. It will become 20 R here. 20 R, and here it will become 16 R is equal to 4 into 10 power 4. That means R can be written as 4 divided by 16. 4 divided by 16 into 10 power 4. What you can do? Here you can cancel 4, and then 1 by 4 into, then you can write here 100 into 100 divided by 4. It can be written as 25. What is the final answer that you have to put? The value of R that is coming equals to, value of R that will be equals to, here how much the answer that you are getting? Here you have taken it on this side, 4 into 10 power 4 R divided by 16, 4, you have got it. So answer should be 250. This is the correct answer. Should we cross check it? Correct. 2500. This was the answer that we are getting. First, we can't get it. Our calculation was correct. There was no problem in it. And then 69. Finally, the answer was coming 2500. Now let's move to the next question. This one. I hope that this question is easy, so you can solve it in 45 seconds only. Let's see how much you can do it. Easy question, I will say. Simply series parallel you have to do. Nothing else. Seconds. 3, 2, 1. Let's see how to solve this question. Learn how to solve this kind of questions. Always whenever this kind of questions you are looking, try to mention the potentials at each point. Whatever you know you can do. Let's start. This point is A, this point is B. Let's start from here. I don't know about this point, let's make it C. If this is C, I can make this point also as C. Correct? Now, further, this point I don't know, let's make it D. If this is D, I can make this also as D. Now we'll see how simplification will be done for this question. Now start from A. A, what is our first resistance? First resistance is 6 ohm between A and C. This is 6 ohm. Now from C to D, what is this connection? Series combination, and how much effective I can say? C to D. Effective is 15 ohm. Then again C to D, the next one again 15. In further C to D again, can you say 15? See how we are analyzing this. C to D, this is also C to D, this is also C to D. Then D to B. D to B, what is there? D to B. D to B, how much? Now see how to solve this question. These three are in parallel. Parallel means the effective part for these three resistance I can say how much? 15 by 3, that is equal to 5. Now just add all of them. 8 plus 6, that is 14. 14 plus 5, that is R equal to 90. Correct? 19 only, which option is correct? See how easy questions are there. You just have to properly approach the question and that's it. You can easily solve the questions. There is nothing complicated in this kind of questions. Now solve this one. Again a basic question. Just think little bit about the formulas, you will have an answer. Water boils in electric kettle in 20 minutes after being switched on using the same main supply. The length of the heating element should be. Should we start? What you can do? What is the question? A water boil in water boils in an electric kettle in 20 minutes. Let's pick the water boils in an electric kettle in 20 minutes after being switched on. Okay. Using the same main supply, the length of the heating element should be. Now there are four options: decrease, increase for at how much times to its initial length when the water is to be boiled in 15 minutes. If water has to be boiled in 15 minutes. First, let's see what is the power. What is the power? Power can be written as, and it can be written as V square by R. Correct. And what is R? R I told you rho L by A. So it can also be written as rho L by A. First, check with length. What is the variation of power? So from here, can we say power is inversely proportional to length? Correct. And you know one more thing, that power is also inversely proportional to time. Is it clear? Power is also inversely proportional to time. That can I say this length and this time are actually directly proportional, correct? So just take the ratio of both the cases. What you can add power because of supply that is given. Here what is written? Main supply, using the main supply is same. So what you can do? You can simply write L1 by L2 is equal to T1 by T2. L1, let's suppose initially the length is L, L2 I have to calculate, or L initial you can write, and it is L final. But you can write T1 time is how much? 20 divided by T2 time is how much? 15. That means it can be also written as 4 by 3. That means this equation can also be written as L final is equal to 3 by 4 L initial. 3 by 4 L initial. That means what this is telling you about, that the L initial length is decreased by how much? Because obviously this is less than 1. That means final length will be decreased, and by what factor? 3 by 4. Final length will be decreased by what factor? 3 by 4. This was the question. can take a screenshot of this one also. A very simple question. Anyways, I shouldn't give you any time for this question also. Just do it orally. What is the question? In the given circuit, the terminal potential difference of the cell is. Terminal potential difference of the cell. Very easy thing. If anyone knows the basics, they know that terminal potential difference is written as E minus IR. What is the terminal potential difference? E minus IR. What is the battery? 3 minus current. Current you have to calculate. How you will calculate? What is R equivalent? Check that also. R equivalent you can write 4 but 4. These two 4s are in parallel combination. Equivalent it will be 2 and this 2 and this one is series. That means R I can say 3 ohm. That is what is the equivalent current? 3 divided by 3 that is equal to 1 ampere. 1 ampere that means I is equal to 1 into what is the internal resistance? 1. Answer will be simply 2. Answer will be very easy question. You can see this was the question this year previous question previous year 2024. If anyone don't remember that what is terminal potential difference? Terminal potential difference is nothing but the potential difference across a battery. This is the internal resistance that is connected to the battery, and let's suppose you don't know about it. How you can calculate? Let's suppose this point is A, this point is B. I started from B. Then what is the resistance coming in my way? That is battery. This wire I into R. Then what is I am going from lower potential to higher potential, that is I will write plus 3 is equal to VB. Correct? So I can write simply this as VB minus VA. That's my terminal potential difference. I can write it as 3 minus of IR or E minus IR. Both are the same things. In whichever way you want to go. Let's move to the next question. This one. Variation question. Again, I will say formula based question, but maybe a little bit calculation. So, solve it. How many of you got the answer? Comment down in the comment section. Let's see how to solve this question. Formula based question. Ratios of wire at 0 degrees Celsius, 100 and 80 degrees Celsius is found to be 10, 10.2 and 10.95 respectively. The temperature T in Kelvin scale is C. What is the relation that I told you in the formula also? RT is equal to R naught 1 plus alpha delta T. What is R naught? R naught is a relation that is at 0 degrees Celsius, that is defined as R naught. So let's see. First it is defined at 0, it is the value is 10. Okay, I will not write it. At 100 degree, what is the value? This is the first I will check that. RT, or I shouldn't write RT, directly I will write the value RT, that means 10.2. 10.2 is equal to R naught. R naught is, in the relation, 1 plus alpha delta T. Delta T means I am taking the reference from 0 degree, that means now it is 100 degrees Celsius, that means delta T will become 100. This is the first equation. Now let's write the second equation. Second equation is what? Second equation, what are the relations 10.95 is equal to 10. 1 plus, what is the temperature? T. So alpha delta T, that means T minus 0 degree. Now I read both the equations properly. Now what I just have to do, I will take the ratio. Take the ratio, what will be coming here? 10.2 divided by 10.95. On the other side, this will get cancelled. What is left here only? 1 plus 100 alpha divided by 1 plus alpha into T. Now cross multiply. When you are cross multiplying it, it will become 10.2 into 1 plus alpha T, that is equal to 10.95 into 1 plus 100 alpha. Check here, 10.2 plus 10.2 alpha T, or you can, if you can cancel it out by base. When you solve it, this answer will be coming equals to calculate it and check what is the answer coming. When you are solving it, this answer should come as T will be equal to 475 degrees Celsius. This should be the answer that will be coming. And when this is the answer that is coming, because the question is asking me in Kelvins, or you can write the temperature. Temperature can be written as 475 plus 273. Now you can write in Kelvin. 5 plus 3 8, 7 plus 7 40, 4 plus 1 plus 7 48 is the correct answer. 748 is the correct answer. Simple formula application that we have did, and then we have solved the question. Is it clear? Let's move to the next question. You can take a screenshot from here also. Actually, better if you are taking that one also on the left side and then take the ratio like this here what they have did, so that you will cancel out this alpha term also. Like here, what was the equation that we have written? We have written the equation again. I am writing the same equation. I have written what? 10.2 is equal to 1 plus alpha 100 T. So it is already alpha delta 100. Then you can take the ratio 10.95 is equal to again 1 plus alpha into T. So what you do, better that firstly change the direction of, take it here 1 on this side, 1 on this side, then take the ratio of equation 1 and 2, then you will easily have the answer. So that alpha term will also get cancelled and you can solve it easily. Solve this question. Basic question. Basic formula application. Number of electrons per second in the filament you have to calculate. Power rating is there. Battery is also there. 220 volt of supply is given to the system. So let's see what is the answer that is. See what you can do. The number of electrons flowing per second in the filament. The number of flowing electrons per second, that is n by t they are asking, and power they are given equal to 110 watt. The battery potential difference that is applied is 220 volt. Correct? See, I can calculate. From this relation, can you calculate current? Power is equal to what? V into I. Can you calculate current? Current is equal to how much? 110 divided by 220. That can also be written as 1 by 2. If it is written as 1 by 2, what you can do further? Current is 1 by 2, and current can also be written as n times of E divided by T. And what I have to calculate? I have to basically calculate n by T. So n by T can also be written as current by electron. Current is how much? 1 by 2 into charge of an electron, 1.6 into 10 power minus of 90. So it can also be written as 1 by, this will be going in numerator, 10 power 90, 3.2, and options. Is it possible answer? 1 divided by 3.2. Let's make it more further specific. Let's suppose 100 multiplied by 10 power 17 will be left, divided by 3.2. 100 divided by 3 is nearly around how much? 33. 33 C. This option is coming actually correct. 3 term is coming. That's why I will just this answer. I can simply write 31.25 into 10 power 17. This is the. I know it always. I told you in the final exam you don't have to calculate the exact value. You just have to approximate the values. In this way, be very smart in solving the questions. You don't go for the complete solution. Just approximate the answers. Solve this question. Is anyone understand this question? Very easy one. There will not be taken any time for solving this question. The value of unknown resistance X for which potential difference B and D will be 0 in the arrangement shown. Potential difference between B and D should be 0. What kind of system it is making? What is this condition of potential of B and D should be equal? Remember? Let's start. How we can solve this question? Very simple. If anyone knows about beats on which they have solved this question till now, beats on which it is forming, because beats on which have the property that potential at point B and potential at D will be equal. Let's analyze the circuit. These two are in parallel, 1 and 1. 1 and 1 parallel, that means it can be drawn as 2 parallel. It will be 1 by 2. See here, what it can be drawn. 12 and 12, it will be series, that means 24 and 24 parallel, that means net it will become 12. Come here. This is what X. Firstly, these two are in parallel, that means the net equivalent resistance at this point. It is firstly solve this parallel, that means it will make 6 and X are series, that means 6 plus X will be the final one. And now come here. It is what? 5 ohm. Now it is our beats on beat. If it is a beats on beat, you know that ratio of this resistance and this resistance is equal to ratio of this one and this one. So take the ratio. 12 divided by 6 plus x is equal to half into 0.5. Okay? 0.5 into 2, that means it will become 1, and here 12 is equal to 6 plus x, that means x will be equal to 6. This is nothing but equal to 6. That means which option is correct? D option is simply correct. Which one is question this was? You can take the screenshot also. Solve this question. These kind of questions have always been given in the classrooms also. So that you should be using these values also. Correct what is the way to approach. A wire of resistance R and radius small r is stretched till its radius becomes R by 2. Check how you can solve this question. Let's see how to analyze this question. A wire of resistance R and radius R, small r, is stretched till its radius becomes R by 2. Okay. If the new resistance of the stretched wire is XR, then the value of X is. Initially, the resistance is R. And what is the formula for resistance? Resistance is equal to L by A. What is the formula? Rho L by A. So, what you can do here? Simply apply volume. What is a volume conjugation? That initial volume will be equal to final volume, correct? And what is the volume of a wire? It is pi square r into L. That means what you can write about the initial volume. Initial volume can be written as pi r square into L initial, and finally it will be written as pi. It finally becomes how much? R by 2 whole square into L final. Correct? This is your L initial. So I can say pi will get cancelled from here. R square will get simply cancelled from here. That means R L final can be written as 4 times of L initial. 4 times of L initial. If it can be written, now what you can do? If new resistance, what is the new resistance? Initially, what you can write? R is directly proportional. You can do it also like this. Resistance is equal to what? Rho L by A. That means multiply L and L here, both the places. What it will become? It will become rho L square divided by volume. And volume is going to be same for both the cases. Simply R is directly proportional to L square. And I hope that you remember this result. This is a very standard result. So I can say simply R is directly proportional to L square. R dash is proportional to finally what is the radius? 4 L square. That means what you can say about R final can be simply written as L square will get cancelled, and 16 R initial will be the answer. That means 16 R is the answer. That means X is equal to what? 16. Correct? This was the way that we can solve this question. I will apply the concept of volume conservation. That volume is always safe. You can take this screenshot also. Now solve this easy question. The ratio of heat dissipated per second through the resistance 5 ohm and 10 ohm given below. Very easy question. Just calculate how much current. We will learn how to calculate the current in our branches also in this question. See how. Answer is very simple, but we should understand what are the concepts also. See, first tell me quickly that how much net current is flowing. Before calculating the net current, R equivalent how much you can say? R equivalent I simply I can say 20 plus what is the series ratios? 5 divided by 15. Simply it will be going 3. That means it will become how much? Not very good answer. 60%, that means 30 by 3. How much it is coming? 70 by 3. Then this is the complete net current that is flowing into the circuit. Can you tell me what is the current that is flowing? What is the current that is flowing through here? Anyways, if the resistance is less, the current will be more. So I can also say that I1 by I2 will be equal to I1 resistance is less, that means current will be more. That means it can also be said as 10 by 5 ratio. So this ratio will be equal to what? I1 is equal to 2 times of I2. I1 is equal to 2 times of I2. Why? Because in I1 circuit the current is very less. So directly you can do it from here. Otherwise, this was the second approach that you can do. Calculate how much I1 you can write. I1 you can write simply how much. Check. This one is 0. If this is 10, current I is going to, you have to calculate what is the potential at this point, and the same potential difference will be coming at this point also. This is 0. This is also B. This is also 0. Then you can check what is the current calculated in. But that is a very long process. So better follow this ratio. It is distributed into inverse law. Also we say that current is distributed into inverse ratio. Inverse ratio it is actually. So what we have to take the ratio of heat energy dissipated per second. That means rate of energy flowing per second is called as power. Nothing but power is equal to what? Power is equal to nothing but I square R1, and this is P1 divided by P2. That is equal to I2 square R2. See, I1 square at the base of I1 square I can write 2 I2 square into what is R1? This is R1 5 divided by here I can write I2 square into I1. Actually it will become 4, sorry, because the square is there, into R2 is equal to nothing but 10, and this will become 2 times, this will completely get cancelled, and the final ratio will become P1 by P2 is equal to 2, or 2 you can also write 2 is to 1, 2 is to 1, which is the correct option. Option B is the correct answer. So simple question. Just this analyzation that you have learned from here, that current is distributed into inverse law. Solve this question. Think properly about this question and try to have the answer by yourself. Question is actually very easy. But the statement may be confusing you. So that's why I will give you some extra time also, so that you can read the statements properly and understand what the question is actually asking you. When you understand it, it is very easy. That's it. Please solve it. Fine. Now let's follow me to check how to approach the question and how to understand what is saying in the question. A wire of resistance 20 ohm is divided into 10 equal parts. A wire is there. Let's suppose this is the wire. It is connected into 10 equal parts. Let's cut it down into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 10 equal parts, that means what will be the ratios for each part? Can you say all those parts? 2, 2, 2, 2, 2, 2, 2. Fine. I hope that it is 10, even if it is not, you can understand. A combination of two parts are connected in parallel and so on. Combination of two parts, that means this is a combination, this is a combination, this is a combination, this is a combination, 1, 2, 3, 4, and this is a combination. All these combinations, a combination of two parts are connected in parallel, so on, and resulting pairs are connected in parallel combination and now resulting pairs of parallel combination connected in series. All these two are connected in parallel. Now see, if these two are connected in effective resistance, that will be coming from here, one, from here, one, from here, one, from here, one, from here also, one. This is clear because if two are connected in parallel, that means effective resistance is one. If the effective resistance is one, now the resultant pairs of parallel combination connected in series. Now all these resistance are connected in series. That is simply add up them. What is the answer that you will be getting? 5 will be the final answer. Question was very easy, but you can be confused in the statement, and when you are in panic situation in the exam, obviously you are going to leave these kind of questions according to mentality. So firstly, we always remember that you don't have to panic. See how easy this question was, but you can make faults in the statement. So it was very good question according to the statement. That's why I also given you some extra time for this question. Solve this question now. This question is easy. 45 seconds is a lot of time for you to get the answer. Very basic question of current electricity. Even without calculating the electricity. Now see. What the question is asking, firstly we will read the question properly so that we are not making any mistakes. Question is saying that R1 is given 10. Okay. I should use an R2. R1 is given 10. R2 is given 8. R3 is given 4. R4 is given again 8. Battery is ideal with 12 volt, that we can see. The equivalent resistance of the circuit and the current supplied by the battery are respectively. Very basic question. Simply name the potentials. This will be 0, this will also be 0, this will also become 0. If this is 0, this will be 12, and I don't know about this will be, let's suppose, become B, this will become V. Now, what I can see, I can say that what is the potential difference across R3? What is the potential difference across R4? V. What is the potential difference across R2? Again, V. So, can I say across all these three, the potential difference is nothing but equal to V. That is can be parallel. If all of these are in parallel, what I can say 1 by R equivalent for how much this portion of the circuit I am just calculating. This will be equal to 1 by 8 plus 1 by 8 plus 1 by 4. What else you can say? 1 plus 1 plus 2. That means 4 by 8. That means R equivalent you can write. That is 2. This is not R because there is one more resistance that is connected. Now that resistance will become coming in series. That means final R will be written as 10 plus 2 ohm. That is 12. 12 ohm. These two options are already eliminated. Now, if the equivalent resistance is 12, what is the net current that is flowing into the circuit? I can write as EMF divided by the resistance. What is the EMF? 12. What is the resistance we have? That is also 12. Answer will become 12 and 1. The option is 1. Very basic and very standard question that also given in the class notes by all the classes. So I have told you about this question in the classes. Solve this question. Again, a basic question of electric lamp. Power dissipation you have to calculate. We start analyzing. How many of you got? This was a basic question. There is a pattern for solving this kind of questions. First, we take the given values. Electric bulb is there. Power is 50 watt. Battery it can be connected with 200 volt. Is connected across. this is a power rating and a voltage rating where it can be operating, but it is connected across 100 volt supply. The power dissipation of the bulb is when it is connected across 100 volt battery, what is the power dissipation? What is power we can write in terms of voltage V square by R. Firstly, from this standard one, calculate what is the resistance of the bulb. That will be always same. Resistance can be written as what is the voltage 200 into 200 divided by what is the power rating 50. This will be 4. Answer will be 800 ohm. Once you got 800 ohms, now you have to calculate power for the second case. Power that is dissipated again. You can write V square by R. V square is how much? 100 into 100 divided by what is the resistance you have calculated? That is equal to 800. That is how much the answer will become. You can divide it by 25 by 2. Answer will be 12.5 watt. So you have calculated power 12.5. Is it clear? Is it clear this question is? Simple. This way you can analyze this question. Now solve this question. Again the same kind of question that resistance is power. That question that we solved that R is proportional to L square. Think about this question. Let's see how to solve this question. The question is wires, two wires are there, A and B, are made up of same material and have the same mass. Same material and same mass. Wire A has a radius 2 millimeter. And wire B has the radius 4 millimeter. Same material and same mass. Wire the resistance of B. Resistance of B is given to you. The resistance of Y A you have to calculate. What is the resistance formula? Resistance is nothing but equal to rho L by A. Rho L by A. Let's eliminate the term of length from it because every value are given regarding the radius. So how you can eliminate? You can do thing multiply here by A. That means you have to multiply here also by A. That means what I can say V divided by A square. Now what I can say this volume or density are going to be same for both the cases. That means I can say from here that resistance is inversely proportional to area square. Area square, that means if it is area, that means it is proportional to R square. If it is area square, that means it will be proportional to R power 4. That means what I can say R1 by R2 is equal to R2 by R1 power 4. R2 by R1 power 4. That means what we can say. What is the R2? R2 is equal to or RB is equal to 4. R1 is equal to 2 power 4. And here R1 divided by RB that you have calculated. It was given to 2. It will be equal to 2. That means R1 can be said is equal to 2 power 4. 2 power 4 is nothing but 16. 16 into that is equal to 32. What is the answer coming? 32 ohm. Let's cross check it from next slide. 32. The answer was coming. You can take the screenshot also. So same kind of second question we have solved. Now there is a question of meter bridge. But the concept that I told you, formula is just simply taking the ratio of the resistance and the null point that you are getting. We'll understand how to solve this kind of questions. All these questions of meter bridge following the same pattern, so it will be clear to you. First, try to solve it by yourself. start the question. Read the question properly at least so that when we discuss, we will understand the question very better. A meter bridge when the resistance in the left gap, in the left side the resistance is 2 ohm. Unknown resistance in the right gap. Let's suppose X. The balance length is found to be 40 centimeter shunting. Now the second case is there. Firstly, analyze the case 1. Case 1, I told you that ratio of the resistance and the this length. Balance length, you have to take the ratio. On the left side, what is the resistance? 2. What is the length that is coming? 40 is equal. On the right gap, let's suppose the resistance is X and the length will be on the right side will be 60 because the total length is 100 centimeter. Now from here, what I can do, this simply will get cancelled. This will become 2, this will become 3. What you can say about X? This X is nothing but equal to. But after that, some question is also there. Now what is the next question? Saying on certain the unknown resistance with 2 ohm, on certain the unknown resistance with 2 ohm, the balance length changes by certain you are applying a new resistance of 2 ohm in parallel. If it is in parallel, then what you can say R equivalent on the right side it will be now equal to this 3 into 2 divided by 3 plus 2. 3 into 2 that is 6. 6 divided by 5. Correct? X was 3. Unknown resistance you are connected 2. That means what will be the R effective? 6. Now again the ratio. On the left side everything is same. Setting the unknown resistance. Everything is same. What you can say here 2 divided by L is equal to on the right side it is 6 by 5 divided by 100 minus N. This is the rest part of the question. Now check which one is the correct answer. This will get calculated 3. What is left? Take it here. What you can say 500 minus of 5 is equal to 3. If it is 3, what you can say 8L is equal to 500 L minus 500 divided by 8. Now calculate how much you will get if you are dividing it by 2, it will be 4, it will be 250. If you are again dividing it by 2, it will be 125. 125 divided 125, it will be coming as 62.5. Well, this question is correct. I can say simply C options. That is equal to how much? 62.5 centimeter. Then and calculation that is correct. Here you have calculated correct. X is equal to 3. Then it was Okay. So it will not. Wait, wait a minute. Actually, it is a good question. They have not asked the new balance. They have asked the balance changes by the balance changes by. Initially, what was the balance length? 40 centimeter. The new balance length is how much? 62.5 centimeter. So how much it is changes? It is changes by 22.5 centimeter. So actually, option A will be correct. That is a very good question. Don't make this kind of mistake. The question was not asking you the balance length. They are asking you what is the change in the balance length that is coming. So it will be 22.5. Current current is equal to 3t square